Hello and welcome to Physics with Amol sir. So this video is for class 12 and we will continue with the chapter of moving charges and magnetism. So previously we saw the concept of velocity selector and the working of cyclotron. Now cyclotron has actually been deleted from the CBSE syllabus this year. Okay, but I felt that this topic was very interesting and that actually helps us to understand these concepts very properly, because this is one of the best applications of the crossed fields of electric and magnetic fields. So that is why I included that topic, but don't worry, it is not in the syllabus. So even if you found it difficult to understand, you need not worry. Today we will talk about a very important law that is called as the Biot-Savart's law. This law helps us to find out the magnetic field at any point. Okay, so let's begin. Now let us start with the Biot-Savart's law. And as I said, this law will help us to find out the magnetic field at any point. Now we have to remember that for magnetic field there has to be a moving charge. Okay, so a moving charge is the origin of any kind of magnetic field. Even if let us say we have a bar magnet, inside the bar magnet also there are moving charges. Okay, these charges produce dipole moments which actually create the magnetic field around it. So always remember, any kind of magnetic effect, any kind of magnetic field is actually arising from moving charge, that is nothing but an electric current. Okay, so now let us start with the Biot-Savart's law. To understand Biot-Savart's law, imagine we have a very long conductor like this. Okay, it could be any kind of wire, right? It could be a straight wire, it could be a curved wire like this. So we have a long conductor. From that conductor there is a current I that is flowing through the conductor. Okay, and we are going to imagine a small length element of that conductor. Let us call it as dl. Okay, so dl is a small length element. Then there is a point P which is at a distance r from dl. Okay, so Biot-Savart's law will tell us that the magnetic field at P due to the length element dl is directly proportional to electric current and inversely proportional to the square of distance between them. Okay, now let us write it mathematically. So Biot-Savart's law will say that the magnetic field at P, I have written it as dB. dB because this is due to a small length element. Okay, because of the entire wire it will be capital B. Because of small length element it will be dB. So this magnetic field here dB is directly proportional to electric current going through the wire. Okay, then length element dl. Now we will not simply write dl, we will write dl cross vector r cap. Okay, why vector r cap? Because that will help us to give the direction of that magnetic field, and inversely proportional to square of the distance. The distance is r, so it will be inversely proportional to r square. So we will get dB directly proportional to I dl cross r cap upon r square. Okay, now r cap is actually equal to vector r upon r. Correct? Any kind of unit vector can be written like that. So this we will write as, therefore, dB proportional to I vector dl cross vector r divided by r cube. We have substituted this value over here. Okay, so that is how we will get dB proportional to I dl cross r upon r cube. Now I am sure you remember this dl. This is the length vector. Now lengths are scalar, but this is given as a vector direction because it is in the direction of the current I. Okay, now so dB is proportional to this particular format. Now to remove the sign of proportionality we add a constant. So we will get, therefore, dB equal to, the constant we add is mu naught upon 4 pi I dl cross r upon r cube. This is the format of the Biot-Savart's law. Okay, this will help us to give the magnetic field at any point. Once again, let us write. So using Biot-Savart's law, we can write vector dB is equal to mu naught upon 4 pi I dl cross r upon r cube. Okay. Now, of course, the question will ask us, what is this mu naught? This mu naught upon 4 pi is the entire constant of proportionality, and this mu naught is called as permeability of free space. Okay. Now, what is meant by permeability? I'm sure you remember this concept, that is epsilon naught. Epsilon naught we called as permittivity. So when we talk about electric field, to understand how far the electric field would go, the constant we put is a permittivity. Similarly, for magnetic fields, the constant we put is permeability. Okay? As such, there is no other meaning, it is simply a constant. Okay, so to understand how far magnetic fields would go, the constant used is permeability. Okay, these are properties of the medium. So when we have air or vacuum, we write mu naught. If it is some other medium, then of course that will be seen, that will be permeability of that particular medium. That is for a later day. So anyway, so mu naught by 4 pi, that is the constant, and we have found that mu naught by 4 pi is equal to 10 to the power minus 7 Tesla meter per ampere. That is the value of mu naught by 4 pi. Okay, so this is the Biot-Savart's law. Of course, now you can find out the direction of dB as well. So direction of dB will be dl cross r. So this is dl, direction of dl is here, r is going on this side. So dl cross r, dB, that is the magnetic field, would be like this. We should draw a cross over here. This is the direction of dB. Cross, that will signify the magnetic field is going inside the plane of this bolt. How did I find the direction? dl cross r. I have to use my right hand thumb rule. Okay. So this will be for the length element dl. To find the total magnetic field, you will have to take the integration of all the dl. So the total integration will give total magnetic field. And again, as I said, this is an important law whenever we are learning about magnetism. At any point, the magnetic field is found by using the Biot-Savart's law. Now, let us see an application of the Biot-Savart's law. So, using the Biot-Savart's law, we are going to find out the magnetic field on the axis of a circular current loop. So, what is a circular current loop? Imagine you have a loop like this. Okay, so this is a circular loop. There is an electric current I which is flowing through this loop. So this is the loop that we are imagining. There is a current I which is flowing through this loop. Now from the center of the loop, imagine an axis is passing through the center of that loop. So on this axis, we want to find out the magnetic field at a point on the axis. So we have selected a point P on the axis. Getting the idea? This is our circular loop which is placed like this. Now imagine this is a three-dimensional case. Okay, so the loop is actually coming out like this. So this is how the loop has been placed, and this is the axis that is passing. Okay, we want to find out magnetic field at P, and we are going to use the Biot-Savart's law. So what are the cases we consider here? We will consider that dl, that is a small length element. Okay, then OP, this is the x-axis, this is the y-axis. Right? Radius of the loop is capital R. Then point P is at a distance x from the center of that loop, and point P is at a distance small r from the length element dl. Right? So this is the overall case. Using the Biot-Savart's law, the magnetic field at P due to the length element dl will be given by dB equal to mu naught by 4 pi I dl cross r divided by r cube. Correct? So this is the magnetic field that we are going to get at P. Let us call this as equation number 1. Right? Now, if you look at the diagram, you can see we can apply the Pythagoras Theorem. So using the Pythagoras Theorem, we can write r square is equal to capital R square plus x square, and we can call this as equation number 2. Make a note of both these equations. We will erase them. So if you notice dl and r, okay, you can notice that both of them are making an angle of 90 degree with each other. Correct? Because you can see this dl will be along a tangent to the circular ring. Correct? And r is going towards P. So therefore, the angle between dl and r is going to be 90 degrees. So from equation 1 we can write dB is equal to mu naught by 4 pi I dl r upon r cube. Then this gets cancelled and I get therefore dB is equal to mu naught by 4 pi I dl upon r square. Let us call this equation number 3. Okay, you will see that here we are taking only the magnitudes. Then using equation number 2, in equation number 3 you will get dB is equal to mu naught by 4 pi I dl upon capital R square plus x square. Let us call this equation number 4. Keep a note of all the equations. Due to lack of space, I have to keep on erasing them. But anyway, so now you have found out the magnetic field at P due to the length element dl, that is equal to dB. Now you can also, you can understand what will be the direction. The direction of dB will be like this. Okay, this will be the direction of dB. Why like this? You can find out it will be dl cross r. Okay, so dl is going like this. Here we have r. So using the right hand thumb rule, you can see dB. The thumb is pointing to direction of the magnetic field. Okay, so this is how dB is going to be at point P. Now we can resolve this magnetic field into two parts. One will be along the x-axis. This we will call as dBx, and the other will be along y-axis. That let us call it as dB perpendicular. Correct? So there are two components of this magnetic field. One is along the x-axis and the other is perpendicular. Like this, we can find magnetic field due to all the elements on that ring. Correct? When you add up all the elements, you will see that only the dBx element is getting added up, and the perpendicular elements will get subtracted. I mean, they will cancel each other out. How they will do that? For example, one element was here. The other element is on this side over here. So what will happen? The magnetic field due to this length element would be like this. Correct? So dBx will get added up, but the perpendicular element, they will get cancelled out. So all the perpendicular elements get cancelled out due to the entire ring. What is remaining is only this element that is along the x-axis. Correct? So when we want to find out the total magnetic field, it will only be due to the elements that are along the x-axis. Correct? That is what we have to keep in mind. So now we can write dBx equal to dB cos theta. Correct? I am sure that also you understand very well. Okay, the element along the x-axis. So this is theta for us. Theta is the angle made by dB with the x-axis. Because this is theta, this angle over here, okay, that this radius is making with this line from going from dl to P. This angle also becomes theta. Okay, so we can write therefore cos of theta is equal to adjacent upon hypotenuse. Adjacent is capital R, hypotenuse is small r. Correct? And small r you can actually write r upon, you can write it as r square plus x square under root. So cos theta can be written like this. Let us call this equation number 5. Now using equation number 4 and 5 here, we can write dB we know is equal to mu naught by 4 pi I dl upon capital R square plus x square, and cos theta we found out is nothing but r upon r square plus x square to the power 1 by 2. This bracket multiplied by this bracket we would get r square plus x square to the power 3 by 2. So we can write this as dBx equal to mu naught I dl capital R upon r square plus x square to the power 3 by 2. This is the total magnetic field at this point. Okay, and to find out the entire magnetic field that is developed on this point, we will have to take the integration. Okay, so if we integrate, so the total magnetic field we can write capital B is equal to integral of dBx. Okay, and since it is along the x-axis, we can simply write it as dBx I cap. The total magnetic field will be capital B equal to integral of dBx I cap. Okay, and we have found out dBx we found out is equal to mu naught upon 4 pi I dl into capital R upon r square plus x square to the power 3 by 2. Okay, so when we are taking integral, all these are constants, they will come out. Okay, only thing that is variable is this length element dl. So when you take integral of dl, you are going to get the circumference of that circle, which is nothing but 2 pi r. So then we will get the equation mu naught by 4 pi I as it is, integral of dl we will get 2 pi into capital R into R upon R square plus X square to the power 3 by 2. R into R will get R square, this 2 pi and 4 pi will get cancelled, and finally we will get the magnetic field equal to mu naught into I R square upon 2 R square plus X square to the power 3 by 2. This is the required equation. The direction will be along I cap. Okay, so using Biot-Savart's law, this is the magnetic field we get on the axis of a circular current loop. One special case we can write that at the center O, you will get x is equal to 0. Correct? So this equation would become B is equal to, I forgot to write here, B is equal to mu naught I. Since x is 0, this will become R square to the power 3 by 2. So it will become R cube. So R square upon R cube will get only R. So it will become mu naught I upon twice R. Okay, so this will be the magnetic field at the center of the loop. Okay, and again the direction would be the same, that is I cap. So what you understand from this, that if there is a circular loop, the magnetic field will always be perpendicular to the plane of that loop. Okay, so if there is a current that is going in this loop, magnetic field will be perpendicular. If the current is going like this, okay, the magnetic field is perpendicular in the upward direction. If the direction of current is opposite, that is current is in this manner, the magnetic field will be going downwards. But always it is perpendicular to the plane of that loop. And at the center of that loop, the magnetic field is given by mu naught I upon 2R. Right, and at any other point on the axis, it is given by this equation. Okay. Now, from exam point of view, this equation, this entire derivation is very important. So make sure you have followed it. So I hope both these concepts were understood, both the Biot-Savart's law and its application. In exam, these questions are definitely asked. Okay, so make sure you understand them. Go through the textbook as well, and in the notes that I have shared with you, all these answers are given step by step. Okay, so even if there is any doubt you are having in these videos, you just look at the steps, all your doubts will be clarified. And even if then there are doubts, make sure to ask. Okay, so that's all for now. Thank you.